All right, so when we pull or push an object at an angle, we have to do our math with respect to whatever angle it is. Whatever angle it's on, the cosine goes with the adjacent point of reference. So in this case, the angle is taken like from the horizontal, so it's like, you know, like up from the horizontal. So the cosine goes with the horizontal component. The horizontal component of this drawing would be ftx. ftx is equal to ft times cosine of theta. And you have to remember, again, your calculator must be in degree mode. If your calculator isn't in degree mode, you will get the wrong answers. So make sure your calculator is in degree mode. The opposite to that would be the y component, or the vertical component of the tension. So the vertical component of the tension is the tension force times sine of whatever angle is taken. Okay? I would like for you to memorize these equations, because I may or may not give them to you on the test. I'd like for you to already have them memorized. Plus, they'll be on your homework tonight. You have about 5 homework problems, so they'll be on that. It says, for example, you have a 15 kilogram box is pulled with a force of 3.2 newtons at an angle from the horizontal of 27 degrees, but it doesn't move. Okay, so what we've got, I've got like a 15 kilogram box. Okay, so it's 15 kilograms sitting here, and it doesn't move. So I'm pulling it at some angle taken with respect to the horizontal. In this case, that's 27 degrees. And I'm pulling it with 3.2 newtons, so that's my Ft. Okay? So the first thing you're going to have to do is draw a force diagram, and then I want you to solve for all forces. I forgot to write that, didn't I? Solve for all forces. So the first thing you're going to have to do is draw a free body diagram. Okay. So a free body diagram of this thing right here that we've got, you have a 15 kilogram thing. It has weight, so it has Fg. It's sitting on a surface, so it has normal. It's being pulled, and it has 2 components to that. So you would say that that thing is being pulled up and to the right. So you'd have 2 vectors, one up and one to the right. Your up one is your Fty. Your side one is your Ftx. Because it's not moving, I also have the presence of friction. So friction is going in the opposite direction of the Ftx. Okay, so that's the free body diagram. Okay, so if I were writing the summation equations, okay, my F net in the x is equal to friction plus Ftx, and that equals 0. My y component, my F nets in the y, that's equal to Fn plus Fty plus Fg, and that all equals 0 because the thing is not moving. This is in static equilibrium. Okay, the next thing I would need to find out, I can find out my Fg, so that's easy, right? Because Fg equals mg. M is 15 kilograms, G is negative 9.81. Okay, so that would be negative 147.15 newtons. So that's my Fg. So I can find that. Now, according to those 2 equations that I put in your notes at the top of the page, I can also find my Fty and my Ftx. So let's find all of those. So Fty equals Ft sine theta. So my Ft in this case is 3.2 newtons. So it's going to be 3.2 sine, and my theta is 27 degrees. So you can plug that in your calculator. Just make sure it's in degree mode. It is. Okay, good. All right, so I get 1.45 newtons. And because of the way I've drawn it, my FTY is going up, so that means my FTY will remain positive. If it were going down, it would be negative, but it's not. And then I can do my FTX, because my FTX is FT cosine theta. So that's 3.2 cosine 27. And that's drawn to the right, so what sign should it have? Positive. Good. Okay, so put that in the calculator. Okay, so 2.85 newtons. All right, so I've solved for 3 of my forces, right? I've solved for Fg, I've solved for Fty, I've solved for Ftx. The Fty is called the vertical component. The Ftx is called the horizontal component of the tension, okay? So the only other 2 things I need are my Fn and my friction, okay? So according to my Fx, right, my friction is equal, it's going to be equal to negative of my Ftx. So my friction is equal to negative Ftx, which is going to be negative 2.85 newtons. So there's one. The Fn is a little harder because my Fn is equal to negative of that plus negative of that. So that's a little more complicated, okay? So my Fn equals negative of Fty minus Fg. So that's, my Fty was 1.45, so that's negative 1.45 minus Fg was negative 147.15. Okay, I'd probably just stick that in my calculator because that's a lot of negatives, and I don't want to get a bad answer because that would be a negative score. Sorry, that's funny. All right, so negative 1.45 minus negative 147.15, bless you, equals 145.7 newtons. And those are all the forces. I could go even one step forward and ask you to calculate the mu of static friction. So that's not too much harder, so we can employ our friction thing. Well, mu, according to your formula sheet, is equal to friction over normal. It shouldn't have a sign attached to it, so even if friction is negative, like it is in our case here, we're going to make it positive for this equation because this equation should not have a negative number coming out of it. Mu should always be positive, and it should never have units. It's a magnitude with no units. So let's see, so my friction, so it'd be 2.85 divided by 145.7. So I get 0.0196. And that's it. Those are all the answers I could find to solve this one problem.